Hi everybody, welcome back. I am Mrs. Cofield for those who don't know me, and today we have
Mr. Madsen.
All right, we're going to do a little bit with some conic sections. So this is our fourth unit for the semester, and we actually last class talked about some circles, which is a type of conic section. So you can see your learning targets are there, and we'll jump right into it. So Mr. Madsen, what is a conic section?
Well, imagine taking, say, your orange tree cone,
Okay.
taking two of those and putting one head to toe on top of the other.
Okay.
And from there, slicing those cones. What type of shape is made from the slice?
Okay. So this intersection of this right circular cone and this plane, it's a little bit tricky to kind of visualize. So we found for you a visual representation here. And I'm going to push that button so we can see it better. So we have the blue cone on the top. We have a blue cone on the bottom.
Right.
So we're going to slice up some cone here. And when we slice our cone, to get a circle, how do we slice?
So for our circle, we're going to slice perpendicular to the height of the cone.
Good.
Which is equivalent to being parallel to your base.
Okay. Now the reason we don't typically say parallel to the base is because these cones actually do go forever.
That is correct.
So that's why we're talking about this axis in the middle and the perpendicular piece. And you can see that the cone is hollow and the plane is going to slice off what looks like a circle.
Right.
Okay. Now if we continue, Cofield hits the right button. Here we go.
All right.
All right. So what if we take our slice and let's change it now. What's going on here?
Okay. So to create an ellipse, we take that plane and now we're going to slice through the cone at a slant.
Good.
And we're cutting right through the cone from one end to the other.
Okay, so where the plane is no longer perpendicular to that vertical axis.
Right.
Okay, and if we let this run a little bit more, you can see that's going to create an ellipse.
So it's not quite a circle, but it sort of has that similar idea.
Right.
I guess what we call it in kindergarten, an oval.
Right.
Is that the term?
Right, that's the term. Okay, next slice. We're going to take the slice this time, and we're going to purposefully make the slice so that it is parallel to the edge of the cone. And then you can see that this time, if I can stop it in the right spot,
there you go.
It's going to intersect just this bottom cone, and it's going to make our parabola.
Yeah. Okay. So remember, what's crucial about that is being parallel to the side of the cone.
Perfect.
Okay.
Okay, so we've got perpendicular to the axis, we've got it at an angle to the axis, and then we've got parallel to the side of the cone. Okay, so the last of the four conic sections. Now, what if we take our plane, and what are we doing this time? I missed.
Well, what's different about this case is we're not just talking about one cone. Our plane is actually slicing through both of the cones.
Correct.
And I think it's safe to say we're parallel to that axis.
We are. We're completely vertical in this case, parallel to that vertical axis. Okay. And since we hit twice, we're going to make two branches, if you will. And this one's called the hyperbola. Okay?
Good.
So, here's our four conic sections. Okay? These are the basic conic sections. Now, there are some other degenerative conic sections. We'll talk more about those in class, but these are the non-degenerative conic sections. And these are shown.
Riffraff.
So let's start with a circle here in the middle. Here's our plane, and it was perpendicular to that axis. Okay, and then if we take our plane and we angle it just a little bit,
there's the slant.
Then we'll have our ellipse.
Okay.
And then if we take our plane and make the plane parallel to this. These two don't look like it, but they are parallel because one of them is coming out the screen at you.
Yeah.
And then we have our parabola.
Right.
Okay, so then on the right-hand side, if we're looking at both cones now, complimented me, shouldn't have done that.
We're getting it.
Okay, then we have our hyperbola, which makes the two pieces together. Those are the four conic sections. Today is all about which one is which. Okay?
So what you need to realize about these guys is they can be expressed and generalized, and we can create them and create their equations.
Right, and what's funny is that all of them can be created by the same equation.
Yep.
Okay, a couple of things to notice. Some of the textbooks that you'll run into will refer to a circle as just a fancy ellipse, a very specialized case of an ellipse. We'll talk about that more when we get to the ellipses. And once again, we're going to study not only the algebra to these things, but also their geometric definitions and why they're defined as such. Okay, that's more for a later day. We'll do that when we get to each of our other three shapes.
Right.
But that equation we were talking about that we can generalize is going to be x squared plus bxy plus cy squared plus dx plus ey plus f.
It's a lot of letters.
Phew, it is a lot of letters. In fact, which ones are going to be the letters? Which
Yeah,
ones are
really.
the variables?
Yeah. I mean, some of these are representing numbers and some are representing constant values. And there you go. And so x and y are going to be the two variables. And so we're still, even though the shapes that these are created from is three-dimensional, the shapes themselves are two-dimensional and therefore expressed on an xy graph, a two-dimensional graph.
Right, because it's the intersection of two things.
Yes.
Very good. Now, it is important to notice that A, B, and C are not all zeros. Some can be zeros some of the time, but they can't all three be zeros.
At the same time.
What would we have if all three were zeros?
Oh, let's see here. That'd knock out the x squared, the xy, the y squared. We'd just be left with an x and a y of degree 1.
Huh,
Sounds
I think
a
that's our line.
Standard form?
Yeah.
Okay.
So that would be one of those degenerative.
Yes.
More on that later. Maybe.
Degenerate. All right.
Okay, so how are we going to tell which one is which? Well,
Okay.
as in the case of our quadratic function,
Oh, yeah.
we used what was called the discriminant to decide what that quadratic looked like, to decide how many zeros the quadratic function had.
Okay.
So you may or may not be familiar with this discriminant, which is b squared minus 4ac, coming from ax squared plus bx plus c.
Ah.
So the general quadratic formula. Okay?
Gotcha.
So remember, we're dealing with now this big nastiness, the ax squared plus bxy plus cy
Wow.
squared, yada, yada, yada.
Got it, yes.
Okay? So we're
Yes.
dealing with that. And all we really care about are the
Uh-huh.
capital B, the capital A, and the capital C. So, Mr. Madsen, run us through this here.
All right. So it's the values A, B, and C that really drive the train and ultimately lead to the type of shape we're going to be dealing with. And
So we're still doing a discriminant. So
Yes.
we're still doing the b squared minus 4ac?
correct.
Okay.
We're still dealing with finding the right value for B, A, and C. Those are constants.
Okay.
And we pull those out of the big old equation that we just showed you on the last slide.
Right. So now, if our discriminant is greater than 0,
Okay. Greater than 0, you're dealing with the hyperbola. All right, here we go.
okay? So if I do my math and I get a value that's positive,
Right.
I'll have a hyperbola.
Exactly.
Okay.
So you have a real number. It's going to be positive hyperbola. It's quite possible that after you throw all those numbers into the discriminant, you end up with 0.
Okay?
In that case, you're dealing with a parabola,
Alrighty.
as we will see. And then it turns out that when the discriminant's value is less than 0,
Okay? So if I
And-
get a negative number from that,
if we end up with a negative number, the shape is an ellipse.
okay, so notice we've kind of only talked about 3 of the 4 shapes.
Yeah.
But
somebody's
the
missing.
reason why is because the circle, remember,
Uh-huh.
is a special ellipse.
So
So we got a rule for that too, right?
yeah, because I mean, you need to be able to know when you're dealing with a circle, or when you're dealing with just specifically an ellipse that's not a circle.
Right. It's
Yeah.
back to that old, a square is a rectangle, but not all rectangles are squares.
Exactly.
Okay, so we're going to have a circle only when the A value is equal to the C value.
Right. So let's see if I can put this in right there. How's
I
that?
squished you over there, didn't I?
Oh my goodness.
The A value equals the C value, and the B has to be 0.
Okay, so a couple of requirements then.
2 requirements to making a circle.
And both need to be satisfied.
Correct.
Okay.
Alrighty, so let's go ahead and try. Remember,
So-
today is all about which one is which. So Mr. Madsen's going to help us out with an example here. We're in example 1, and we're going to figure out what type of conic we have. So again, that equation, go ahead,
Okay.
Mr. Mike.
There we are.
That equation is from the front screen. It's on a different slide for us, but for you it's on the same paper. So all we got to do is figure out what is our A, what is our B, and what is our C.
Right, so it's the leading value for the A is always going to be the value being multiplied to the x squared,
Okay?
the B to the xy, and C multiplied to y squared.
Okay, so really all we care about in that first equation
Yeah.
is the 3, the -4, and the 2?
That's exactly right.
Okay, so the x squared term coefficient is a 3, so A is going to be 3.
All right. Uh-huh.
And then the xy term is a -4,
Is -4.
okay?
Yeah.
So we're going to have a B of a -4. And then the y squared coefficient would be a 2, so C is 2.
All right.
And then all we got to do is put it into B squared minus 4AC.
So
Is that right?
That is exactly right.
All
not
right.
not bad. With all those letters, it's simply
It's not so bad.
no, it's not so bad.
All right. So what I love that Mr. Madsen's doing right now is he's remembering to square his negative, that he needs a parentheses there.
Always.
Please don't forget that. That's going to drastically change your answer.
Right. Let's see.
12 times 2, 24?
On a good day, right?
Yeah.
All right.
So how about -8?
Ah, thank you.
Feels like Monday.
All right, so negative is my answer, right? And I'm done. So what does this tell us about the shape?
Okay, well, if I go back to the chart you just showed me, you said that if the b squared minus 4ac is a negative answer, then I have an ellipse.
Okay.
So we have a negative b squared minus 4ac, we must have an ellipse. If we had the capability of graphing that shape right there with the 3x squared and the minus 4 blah, 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 we would get an ellipse.
How do we know it's not a circle?
Oh, that's right. So if it's an ellipse, we definitely have to check for a circle. So for a
Right.
circle, the A has to equal the C.
So A and C. Well, let's see. A is 3 here.
Right.
Oh, A is 3 there. C is 2. Obviously not the same number.
Okay, so we're definitely not a circle. We're just an ellipse.
Awesome.
Cool.
All right.
All right, so let me have a crack at one here.
Yes, because I didn't save you much room. Sorry about that.
That's all right.
All right.
All right,
She's
small.
an expert.
Not necessarily. All right, so the A is the coefficient of the x squared. That's a 1. The B is going to be the coefficient of the xy term, so that's a negative 1.
Okay.
I don't see a y
Yeah.
squared.
Yeah. So it's nothing.
Is
I
it
mean,
0?
it must be. It has to be 0. Because we could write a 0. We could add 0 y squared if we wanted to.
We could, and that wouldn't change the problem.
Right.
But it would give us a c value of 0. So if we're going to come back to our b squared minus 4ac, we're going to have a negative 1 squared minus 4 times a 1 times a 0. Hey, I like multiplying by 0.
Nice.
My discriminant then is just going to be a 1. So last I checked, 1 equals 1.
Yes.
And what do I do now?
Well, now you go back to the rules of the discriminant.
Okay.
The value of 1 being greater than 0 tells us that this bad boy is a hyperbola.
Hyperbola. Okay. By the way, if you say hyperbola, you put the emphasis on the wrong syllable.
Syllable.
I just like saying emphasis on the wrong syllable.
Nice.
So there's got to be a way to get these equations into what I have dubbed, this is my own made-up word,
And we're going with it.
as a transformational form. A form so that I can easily identify the transformations.
Right.
Okay? In order to do that, we get to...
What would it be? Oh yes,
we
complete
get
the
to
square.
Complete the square. You thought that went away.
So remember the idea behind those transformational rules was all based on inside opposite,
Yep.
outside same. That's what we're going back to here.
Okay? Now, because we have so many letters, we may need to, get to, have to, fill in a verb,
yeah. This-
complete the square for
For-
x or y, or both
So in one problem?
in one
Oh
problem.
my goodness.
Aren't these fun? Okay, so let us guide you on how this is going to work.
Yeah.
So we're going to use the discriminant first to identify the type of conic we have. It helps to know what you're dealing with.
Okay.
Then we're going to do a little rewriting.
Okay, yep.
So Mr. Madsen said we first should identify what is our A, what is our B, what is our C.
Yes. So before we jump into all that completely square, again, Ms. Cofield's trying to figure out what exactly conic are we dealing with. Okay. So we got to find A, B, and C, then we're going to throw that into the discriminant.
Correct.
All right.
So tell me what to do.
Well, our A value is going to be the leading coefficient in front of the x squared, which is going to be 1.
Good?
The B value is the leading coefficient in front of the term that has x times y. It's not there, so we're going to use 0.
Perfect.
And then again, C, leading coefficient in front of the y squared. So in this case, we're going to use 0.
So you're going to have pieces missing, and you have to identify which is missing and which are zeros.
Okay?
Okay, so then we could go 0 squared minus 4 times a
Eight.
1 times a 0.
Okay? So a little math on that. And
That's a whole lot
yeah,
of nothing.
yeah. A whole lot of nothing. All
I got a
right.
whole lot of 0.
Okay.
Which means?
So, well, it means that's exactly 0, so we're dealing with a parabola.
Yes, we are this time. Okay. So we got a parabola, and we know that a parabola generally has y equals x squared. Okay? Now,
Right.
we haven't talked about any of the equations yet, and that was on
No.
purpose. We will spend an entire day on parabolas. But for right now, we need to figure out this whole transformational form.
Okay.
I need something squared. Something squared is only going to come when I see the same variable, but
Okay.
I see a squared version of it
Okay.
and a non-squared version of it.
So x squared and its companion x.
Correct.
Okay.
When I have an x squared and an x term, I'm going to have to complete the square on those pieces, which means I am not going to be completing the square on this junk,
Whew.
and I'm going to get it all out the
Yeah.
way.
Get it?
So to complete the square, what I personally would do
Yeah.
is set up something like this. That would be a minus.
Okay. That's all right.
Let's try that again.
So you're moving the negative 8y and the plus 12. We're gonna move that all to the right side.
Perfect.
Okay.
Okay, complete the square. We're going to have half of the middle term. Half of 4 is 2. 2 squared is 4. So I am missing a 4 to complete my square. If I add it on the left,
Well, whether or not you want to, you have to add on the right.
You
right
do,
to maintain
absolutely.
equality.
Okay,
All
so I
right.
still have my equals sign right
Yeah,
here.
so
I'm
what do
going
we
to
got?
combine any constants that I can, and I get an 8y minus an 8.
Okay.
Okay.
Slick.
Now, transformational wise, I can see I've got an inside on the x going on, but it's a little bit difficult on the right side to see the
Yeah.
transformation.
Yeah,
what did
yeah.
we do last chapter?
Well,
we factored!
oh yeah, right.
Factor.
Factor.
So we got x plus 2 squared equals, and I'm going to go ahead and factor, and then I have an 8 minus a
Oh,
y.
look at that.
And oh, looky there. I know that whatever this parabola is doing, it's going left 2, and it's going up 1. Notice this now is an
Well,
inside piece.
So
That's a little tricky. Like with the circle, both the pieces now are inside.
so inside opposite, right?
Right. We'll talk more next class what that 8 is going to do to it, some sort of stretching. Okay? But we have a parabola. Now, if you really wanted
Yeah.
to get the y completely by itself,
Yeah.
you could. But for us, you can stop right there.
Yeah, that's all of the information we need to graph these.
Okay. So, next example. All right, Mr. Madsen,
Oh,
can you
boy.
find us a discriminant,
this.
please?
Okay, so let's go and identify our a values first
Alrighty.
here. X squared's leading coefficient is 1.
Yep.
XY, no
Is
x
missing.
times
No
y.
xy, so that's a
Easy
0.
enough. And we're going to go with our C value. Oh, there he is.
Our y squared is 1. So we're going to go b squared, so 0
Okay.
squared. Okay. Minus a 4 times the a, which is 1.
Oh, hold on. Let's go back. I got a little.
There you go.
0 squared.
0 squared minus
4. A and C.
C is also 1. And again, all we care about is that the answer to this is going to be negative.
Right.
So if I have a negative, I know that I'm dealing with either an ellipse or a circle. So let's start off saying we know it's an ellipse so far.
Okay.
And then, what was the special requirements for a circle?
Well, A had to equal 0. A had to equal C.
Oh, it does.
And that's checked there. We have that.
Okay. And b equals 0.
Ah.
So we do have a circle.
Circle. Yay.
Yay, circle.
Is that yay?
Lovely.
All right.
All right. So do you want to complete the square, or would you like me to?
Better let the pro handle it.
Stop telling me
Yeah,
about
yeah.
it. Okay, so again, Mr. Madsen pointed out we need to have the variable and its companion. We need an x squared
Okay.
and an x.
Okay, so we're going to complete the square for the x's. Uh-oh, but there's also, what does it do? There you go. We also have a y squared and its companion y, so we're going to have to complete the square for the y squared and the y as
Sure,
well.
make me do the one that's hard where you gotta complete the square twice. Okay, so again, I would rearrange these pieces. So
Yeah.
we're gonna have an x squared, and we're gonna have minus a 6x. I'm gonna leave a little space there.
Yeah, yeah.
And then let's put the y's together.
Yeah.
We've got a plus y squared and a plus 12y.
Okay.
Alrighty, and I'm actually gonna go ahead and get rid of, if you don't mind.
Do, by all means.
We already know it's a circle.
Yeah. That
I
looks
can fill that back in up here. It was a circle.
right.
But I'm going to need that room.
Yes.
Save yourself plenty of room for this.
Yeah, yeah.
Okay, now anything that's not an x or a y, well, that's just got to be my 36. So I can come up here and go minus 36.
Yeah, let's move that
minus
to the other
36.
side.
All right. So far, so good?
So far, so good.
Okay, with the blue piece,
So-
I'm going to complete the square on x.
So how did you pick? So how do you decide what number to put in here?
Okay, so once again, when we complete the square,
Okay.
we need half of this value. And we've completed the square about 4 times now. We did it in Unit 1.
Right.
We did it again in Unit 2. We did it last class with circles.
So this.
So we've got to be good at completing the
Gotcha.
square.
Okay.
Okay. Basically, we've got 6x terms. We need to equally divide them. So half of 6 is 3.
There it is.
Okay? Now, to complete the square, we're going to square that 3 value
Okay.
in our factoring, and we're going to get a plus 9.
Gotcha.
Don't forget to add it to the other side. Okay? When we look at the y, I think I explained it okay, Mr.
Yeah, yeah,
Madsen? What do
definitely.
you think?
So that b value at 12,
Mhm.
we're going to divide by 2, and it's
Okay.
positive 12. So dividing 12 by 2 gives us a 6.
Alrighty?
And then to figure out what that, and then squaring it
Okay?
means that we have to add a 36 to both sides.
All right, so I'm going to add a 36 from the, that's red. I almost said blue.
Okay.
From the red part, I almost did it again. From the
Right.
red part of the y, we have to add a 36.
Okay.
And from the blue part of the x, we had to add the 9.
Now we do need a square on that bad boy, don't we?
We do.
All right.
Let's do that.
Rock and roll.
Good plan. Alrighty, so now, when we add all our constants
Yes.
together over
Oh,
here,
that works out, doesn't it?
guess what?
It's not so bad.
That looks like a circle. X minus h squared
Oh yeah, back from the days
Plus
of geometry, absolutely.
y minus k squared equals r squared.
Squared.
Actually, it was just last class.
Oh yeah, you're right. Even from last class, because we just taught that lesson yesterday or
Yeah.
the day before.
All right, one more. Again, pause.
Uh-oh.
Pause the video,
Yeah.
give it a try, and then we'll come back.
And I emphasize this for my students. This is our first video.
Okay.
You guys are not just watching, you're not spectators. You have to pause and try these problems on your own.
Math is not a spectator sport. Pause.
Okay. All right. Okay, so we know that this shape is a hyperbola from the discriminant. So let's take a look at it from here. We want to clean up a little bit. Let's put the buddies next to each other. There we go. So
Right.
9x squared, and then the plus the 90x. Let's set those next to each other. What else we got there? We got a negative 4y squared.
And I'll tell you, Mr. Madsen,
Okay.
that's where kids mess up right there, is
yeah.
they lose track of the little negatives.
Right, everybody-
Be careful.
Oh yeah. The negatives come along for the right, don't they?
They do.
And we're going to throw that negative 115 to the right by adding 15 to both sides. Okay, so we've got, x squared x, y squared y. We've got to complete the square for
We
both
do.
cases.
And this completing the square is a little bit trickier because,
Oh.
well, we don't have a coefficient of 1.
Oh,
So we're going to
man.
have to now factor out a 9 and complete the square on x squared plus 10x,
Right.
and something is missing.
Oh, yeah.
Again, if you need to, grab some colored pencils and do this. Okay? So I'm going to have a 9 times something squared.
Okay.
My half down rule still applies. Look, we're so nice it's an even number.
Yeah.
Okay, half of 10 is
So
5.
square 5, we're going to get positive 25.
Okay.
That works out.
So now, let me leave some space
Yeah,
over
yeah.
here. Over here on the right-hand side, we're going to have an equals 115,
Uh-huh.
correct?
Right.
But I have to add in that 25 that we just used to complete the square.
So we're just going to add 25 to the right.
You would think so, huh?
Yeah.
No!
No!
There's a 9!
It's
so you
not-
have to add 9 times the 25.
See, we didn't actually add 25. We added 9 times 25. We stuck it inside the parentheses.
Right. So be careful. Now, this red part gets even trickier.
Oh, yeah.
Because this is a negative, I'm going to factor a negative 4 out
Yep.
of something. And I know right away over here on the right-hand side, I'm going to have an eraser popping up and being psycho.
Okay.
There we go. I'm going to have a
4
negative
times
4
something.
times something.
Okay.
Okay, so just as soon as you factor, fill that number in.
Okay.
So I'm going to take out a negative 4. I've got a y squared up
Plus.
plus 16y.
So change the signs.
And now I'm ready to complete my square.
Right.
Something squared.
Something squared.
Half of 16.
So we get y, 16 divided by 2 is 8. 8 squared, 64.
All right, so then in my parentheses on the right-hand side, I am
Oh.
missing a 64.
Nice.
But I already have that times 4
4.
set up. Okay? Now, all I got to do on the right-hand side is a
Clean
whole
that
bunch
up.
of arithmetic. Can you help me with that
Yeah,
answer?
324.
Thank you.
You're welcome.
The magic of having a buddy.
Yes,
All right,
indeed.
and we're done.
Well, that's it. That's
We've got
not so bad.
An x squared, so I can see I've got a transformation to the left 5.
Okay.
I've got a up, down.
Down.
I have a down 8. And then I've got to have some stretching and some shrinking going
Yeah.
on here. And again, more on that another day. We're just
Okay.
getting the format correct right now.
Right.
Okay?
Sounds good. Sounds
So,
good.
and we have a hyperbola. Okay, last but not least.
Yes.
Did we notice anything
Yeah.
missing every single time? That one we erased, but
Missing as compared to that big old fat, big long equation. from
right,
the
and
beginning.
specifically to the discriminant.
Okay.
Every single time we did this, the b value was 0.
Oh, look at that.
Okay?
Yep.
The b was 0 because
Okay.
the bxy term is missing. And the reason why is because we don't have the algebra skills right now to complete the square on a
Yeah.
bxy. We'll save that for calculus.
Yeah, you'll
So-
get there.
If you have a bxy term, it must be on the kind of question that's not necessarily completing the square, but that's just identifying the type of function.
Maybe putting it in the general form or something.
Right.
Okay.
Okay. Anything else we noticed about the parabola? We did kind of already mention this. The parabola is either going to have x squared,
or the y squared.
but not both.
Not both. If you have an x squared and a y squared in there,
You're
one
not a
thing,
parabola.
It's not a parabola.
It's
Cool.
going to be one of the other shapes. Alrighty, I think that's it for 8.0 and Introductory to Conics. We will see you in class.
Go get them.